Hey, welcome everyone. I probably should have put on my headphones so that I could get cut out some of that echo here. But how are you all doing today?
Doing all great, Marino.
But I think we've got like
Fantastic. Leon,
Marino,
welcome.
we've got Marino, we've got Akash, and then Leon. It's like a line.
So I think Leon, I don't know what's going on.
Yeah,
But whatever you're talking about is coming through here too. All right. Anyways, welcome everyone. We are going to dig into some network security because we've got, we've covered some things. We've covered off installing Cilium in a couple of ways using the Cilium CLI, and then as well as Helm. And we kind of want to do stuff with Cilium, right? We want to learn networking through Cilium. I'm going to kick Leon off because I'm not sure what's going on with his video or audio, but that's okay. In any case, Akansha, why don't you share some slides, and I'll go ahead and recap some of last week's video. So what we did last week was we actually used Helm, which is a package manager for installing various applications, right? So you can think of it as a mechanism to create parameters for your install, basically saying this is how your install should look like. And then you pass that in, which basically talks to your Kubernetes API, and we'll go ahead and deploy those applications right into Kubernetes for you. It makes it very easy to lifecycle an application. And most of the time, what you would find is that application specifically might be supporting your overall infrastructure. So let's say, for example, we're talking about Cilium, right? Cilium, you can install it using the CLI, which I believe, from what I understand, also uses Helm, but you can also use Helm. Helm actually will just make it very simple overall. But once you've installed with Helm, what if you need to make changes? So if you need to make changes, you can actually use the Helm upgrade functionality, which then allows you to basically make those changes to your install. Let's say you're now enabling the BGP functionality and you're trying to peer with upstream top of rack routers. So once you've kind of sorted that out, now you have BGP connectivity, your pod networks can be distributed, but you just turn that on with Helm. Now, once we've gotten past that install phase and we've got a few applications running in our environment, one thing that we have to consider is we don't want applications to have free roam. Akansha, could you go into presenter mode, by the way? So if you click slideshow up at the...
okay, yeah.
And then there's presenter mode. Let's add Leon back to the stage. Leon's like kind of there. I don't know.
Is it visible?
Yep, your screen's visible. So Leon's not coming back. I'm going to take him off. I'm not sure what's going on. Leon, you might want to exit StreamYard and rejoin. All right, network security. So network security is pretty wide and vast because there's so many different pieces to consider. We have all of these different endpoints that exist in a network. We have laptops, we have servers, we even have printers maybe, and other devices that exist, right? Our phones, we have devices that just need connectivity somehow. Even clocks, a lot of clocks rely on public connections. So one thing to consider is, like, if we have all of these different connections coming in, what we might want to do is also ensure that when we do have connections that come in, we identify who they are, right? But we can also provide some filtration mechanisms, some policy layer. So let's think of it this way. We have two computers that need to communicate with each other, and they're on the same network. Now, if they're on the same network, if they both have IP addresses and they both know about each other, they should be able to ping each other. Heck, we could even do a file transfer pretty easily. And if for whatever reason the default gateway isn't in line, or let's just say because they're on the same broadcast domain, there isn't a gateway that's in line of that traffic, they can freely communicate with each other. So what happens when you want to enforce some policy between them? There's a couple of ways. Long time ago, like many years ago, or literally talking about 15 years ago, there's something called the host firewall that you could have enabled, you could have configured on a Windows operating system. Welcome, Dan. Thank you for entering the conversation. And Leon, I hope your connectivity is stable now. But in any case, when we think about these host firewalls, what you could do is you could implement policy and say, hey, I don't want any of these services that exist on my host operating system to communicate outbound with a certain destination, or vice versa. I don't want certain destinations or certain like sources from outside of my host system coming inbound to connect in to talk to any service, right? So I would use a host-based firewall to be able to handle that. So what's interesting is we moved away from that because managing host-based firewalls, individual systems is troublesome. So you could have done this through group policy, which is something that Microsoft and Active Directory handled. There are other mechanisms to solve this as well through a policy chain or process. But we moved away from that to use centralized systems, centralized gateways. So those centralized gateways or firewalls, they still exist today. Any traffic that exits or leaves a network or enters a network has to be policed by that firewall. It's usually one of those like high grade, very high powered, high CPU, a lot of memory systems. And usually you'll have a couple of them that sit around together that usually sit in an active passive setup, maybe active setup. Active passive, active. What does that mean? It's really around high availability. So when you have active setups of a firewall, there are other issues that come up, but the whole situation is you just want to make usage of all available bandwidth and all available systems to process packets and policy. But in an active standby situation, you have one device that is doing all the processing while another device is just waiting for a failure to occur. This is very like ASA-like. If you have ever worked with Cisco ASAs way back in the day, you would have a pair of them and you'd have a wire between the two so that there would be a failover situation. The secondary device would know about it and would start taking on the operations. That setup is actually still present and prevalent in a lot of different data center environments. I'll stop for a second because Dan is nodding his head a lot. Welcome to the conversation, Dan. It's been a while. How are you doing?
Yeah, thank you very much. Yeah, no, I was away last week. Back this week. Thank you very much for having me. Only just made it. I basically just kind of sprinted across Belgium to get to a random conference hall because it turns out my room's not ready either. So I'm sat in some weird conference room at the moment that they've let me use. But yeah, firewalls are fun contraptions. Managing firewall rules is not a fun thing though. Traditionally, firewall rules end up being leaky ships. As more and more applications come into the world and eventually disappear, you end up with legacy holes left in your firewall, and it can be hard to know who those rules once belonged to and things like that. So kind of amusingly, there's now a whole industry around being able to take your big firewalls and work out which of those rules still is active and which of those rules you can kind of finally carefully delete and make sure things don't break and stuff like that.
Exactly. Oh my gosh. Firewall rule sprawl. What a thing. It was like, you're right. I mean, I worked in an organization where there were a combination of PIXs and ASAs. And one of the biggest challenges is over the years of technical debt, this company also acquired multiple circuits varying in sizes, T1s, DSLs, and even like straight up Ethernet circuits. And the thing is, they didn't even know what would happen if they pulled the plug on one, like what website would go down, what service would go down. And so you're absolutely right. You see a situation where Band-Aids are applied on top of other Band-Aids to solve very, interesting problems. And then you create this much larger problem overall. I'm glad I don't work there anymore, but I don't know where the organization is now. in terms of what they're doing, but it's happened. And Sedant has mentioned something about IP tables. Yes, getting PTSD around IP tables. IP tables is something that's in Linux, so it's a mechanism to do packet filtration and policy at the Linux kernel level. So, yes, go ahead, Dan.
Sorry. IP tables is going to no longer be in the Linux kernel. The next version of RHEL, IP tables has been gutted. It no longer exists in the Linux kernel. For people who are moving forward, it should be NF tables now, which is the de facto way of doing these sorts of things. But and Kubernetes is going to be rebasing kubeproxy away from IP tables to do all of its magic onto NF tables. But traditionally, IP tables, firewall D, and things like that have been the ways that you get PTSD from working with IP tables. Very much true.
I do agree. We will find some resources and share for folks that want to know how to translate from IP, from IP tables to NF tables. I don't believe the configuration is vastly different and the logic either, but it's worthwhile knowing as well. Krish is asking about something. What is HTTPS? I have no idea. HTST, I don't know what that is. Sorry. And then Siddhant is HTTPS, which is something probably entirely different. HTTPS makes sure packets are properly encrypted and certificates are authenticated with the correct CA. Kind of. So that's a partial answer. HTTP is a protocol for the web. And by adding that S, you're actually now injecting a certificate into that request altogether and ensuring that the client and the server can verify, the client can verify the server. The situation where they have to both verify each other is mutual TLS, and that's something we can discuss further. Sebastian comes in and says, HSTS is HTTP strict transport security. That's an interesting one. I've never heard of that. Dan, have you heard of that one before?
Not in that, guys. No, it's I'm quickly on the back googling away.
So I've played around it. I don't know if my audio is all good, but I've played around it with Cloudflare. So it's something that enforces SSL on, like, if you use Cloudflare or something like that, it automatically sort of upgrades the connections and gives you options like that. HTTPS related stuff, but yeah, that's it. Is the network still buggy?
Yeah,
A little bit.
your video is cutting out. Your audio kind of is very minimal, but that's okay. All right.
So it effectively forces HTTPS, as far as I can tell. It's basically something in the headers that effectively means, like, we'll not do any plain text. It's all TLS moving forward.
That's interesting. Okay.
I mean, a lot of this is kind of enforced in most browsers these days anyway. I mean, like, if you use Chrome, for instance, if you go to a website, it will by default effectively attempt to do HTTPS, and it'll start yelling at you if you start putting HTTP in there. Yeah.
HSTS is a header that tells the browser to require HTTPS. I love that. Thank you, Mark. Welcome. All right, let's continue. Now we have a couple of other things to consider: encryption, policy, and identity. So encryption is the concept where you have to safeguard data that's either in motion or at rest. Now, we could get into like the details about encryption, and it really comes down to this idea where you're taking data and scrambling it so that it's not easily readable or replayable. That's the simple way to put it. But the more extended approach is you're using algorithms, various algorithms, hashing and so forth, to basically compute some of this data in another form so that it cannot be transferred back to its original state unless you had a key that allowed you to translate it back to its original state. Now, this has been used forever, especially in IPsec VPNs, where you're actually encrypting traffic that's in motion. So you have these two networks that are islands of each other, and you need to create a bridge between them, you'll use IPsec tunneling to achieve that. But if you're doing this over the public internet, you're not going to send your plain text traffic across the internet, especially if it's personally identifiable information or other, highly confidential information. You will encrypt it. You will make sure that it's not replayed, and you will ensure that it reaches its destination. Now, granted, there are various encryption protocols and algorithms out there that are very, very strong that make it very difficult to unencrypt or decrypt this data. But also, look, we've got like almost unlimited compute power out there. It's kind of scary to think how much we can throw it at a mechanism to be able to decrypt some data. At rest, it's a different situation because you're not having to worry about things moving. You just literally can encrypt a disk. You can encrypt volumes. We could have Michael Cade come in and talk about that if we wanted to, but we'll save that for another time. And then we have policy, right? So policy is kind of related to firewalling because we have a policy which basically says this can do this, this can do that, this is allowed to do X, Y, and Z, or isn't allowed to do something. And we could have multiple policies, we could have multiple definitions in that policy. But in the world of, let's say, Kubernetes, we have something called a network policy, which simply just says, at its very basic level, service A can talk to service B, but service A cannot talk to service C based off of these conditions. And a condition might be because service C has a particular label on it. So, Dan, anything you want to add to that? Maybe we want to talk about the Cilium network policy.
Yeah, I was actually just thinking a little bit about the encryption that you were talking about before we went on to policy. And it wasn't so long ago that kind of encryption was expensive. As you mentioned now, like a lot of encryption is kind of largely affordable. It's done on most hosts and things like that. Certificates, though, are still kind of a little bit expensive. We now have things like Let's Encrypt, which will allow you to generate your own certificates that don't last very long, but it's cheaper than having to buy certificates that you used to have to do in the back of the day. But we used to have to make use of things like SSL termination quite a lot. What effectively that means is that inside your network, we never really had to encrypt anything, but traffic coming in would hit like an SSL termination point. That would effectively, the certs would do their thing. We would strip the encryption from everything, and it would be plain text here on in, saving everything down the downstream, the additional computational work of doing the decryption stuff and things like that. It's nice now that that's largely a non-issue. Most CPUs and things like that can quite happily handle doing all of that sort of stuff with no hit to user land, and it's much easier to get those certificates and things like that, to have them pretty much everywhere. And yeah, policy. So network policies have been part of Kubernetes for a very, very long time. It's effectively a nice way of basically saying these are the firewall rules that will exist within my cluster. But it's much nicer in terms of it makes use of all those Kubernetes primitives, so we can effectively say the pods with this particular label are allowed to speak to this. We don't have to worry about things like IP addresses and ports like we did with firewalls. We don't have to worry about new pods being added to these groups and things like that. We just get all of that niceness that Kubernetes does for us. So it becomes very easy for us to have good policies, and we don't have to maintain them. Kubernetes will maintain what exists in those policies as the life cycle of pods and scaling and all that magic kind of happens as well. And you mentioned Cilium policies as well.
Yeah, we actually have a slide on that, so we'll come back to that in a second. So let's go back to, let's stay on this slide. So we talked about firewalls, we talked about encryption. There's a couple of other things we want to talk about. So packet inspection. Now, packet inspection is a situation where anything that ingresses into a system needs to be inspected. Now, we could do this at a very high level and use very limited sets of attributes to make a decision so that we speed up processing, or we could go very deep and try and decrypt the packet and understand what's in the payload. So there are different styles, and it really comes down to the necessity and needs of, one, your organization, but two, what's available in your own like environment too. With packet inspection, let's say deep or stateful packet inspection, it actually may slow down and add latency into your overall request process. Whereas a stateless approach, we're not really checking state or tracking state. We're just really assessing a generic policy at this point to make sure that it matches. And if it matches, great, we'll go through. So there's a lot of considerations around how you would process that. Now, what's interesting though is like Cilium, for example, allows a lot of flexibility in how you want to customize those particular policies and how you would process packet inspection. It actually doesn't do it it doesn't use it at kernel space, right? We'll talk about that. We'll come back to that. Now there's something else around TLS and MTLS. So TLS is this mechanism, or is a successor to SSL, by the way, but it's a mechanism that allows us to bake an identity into a request. So when we're making a request out to some service, we want to verify its identity to make sure it's a legitimate service. MTLS does that both ways. So as a client, want to verify the server also needs to verify that I am who I say I am as a client. And you might most commonly find this in a service-to-service Kubernetes-based environment where you're using like a service mesh to accomplish this. Now, there are several service meshes that do MTLS or classic MTLS today, but there are more modern methodologies of achieving that MTLS-like functionality with less overhead and some more modern capabilities. IPsec, like I kind of talked about it, it's just a tunneling mechanism, right? And it's still used. It's still used in cloud environments. It's still used across branch locations. If any of you have ever heard of SD-WAN, it's used there as well. And it creates a nice little bridge where you could use the internet. Heck, a lot of us could easily spin up a Linux environment, deploy some open source IPsec variant, and set up tunneling if we wanted to and share our networks. It's actually a lot more complicated than I say it is. Let's move on to the next slide. All right, security within Kubernetes. Oh, go ahead.
WireGuard these days. Sorry, do we talk about WireGuard these days? Isn't that's the way forward, isn't it? That's the new VPN hotness.
Why don't you talk about WireGuard? Let's chat about that.
Yeah, sure. WireGuard was added to the mainline kernel a few years ago, and it's pretty amazing because I remember seeing the commit, because I read kernel commits every now and then. Seeing the commit for WireGuard going upstream into the Linux kernel, and it was a tiny addition to the Linux kernel. Like it's something like 6,000 lines or something or other like that, and it basically implemented a whole new VPN solution for Linux systems and now for other operating systems and things like that. They tend to potentially do WireGuard in userland as opposed to in kernel, but there is an in-kernel implementation in the Linux kernel, things like that. And yeah, WireGuard is a modern implementation of doing point-to-point VPN tunneling. So you set up your WireGuard tunnel, you generate some certs, you swap the certs over. So A knows it can talk to B, A knows how to talk to B, and B knows how to talk to A. You give that information to one another. You do the WireGuard up, and all of a sudden, then you get the point-to-point tunneling, and everything is all rosy, and it just works. And yeah, I mean, there's Tailscale is the company that effectively has built a whole business on making, kind of enterprising the WireGuard, moving it forward and things like that.
You know what? If any of you have some spare cash lying around, pick up one of these GLI iNet like wireless router things. It's a pocket router. It actually has WireGuard as well as Tailscale built into it. And what's really cool is, so once you log into the UI, if you auth into your Tailscale network, now your actual router will be part of your Tailscale network once you enable the turn on the Tailscale button or whatever it's called, which then puts all of your clients that are behind that router on your same Tailscale network. So let's just say you have like EC2 instances or some Kubernetes cluster that lives somewhere else, and you have like they're both Tailscale enabled. You now have your own little VPN network with a click of a button, which is very cool without you having to sit there and manage like credentials or passkeys or passcodes for your IPsec tunnels. Now, there are other considerations too, because like when you're working with production environments and government organizations, certain governments might have like FIPS requirements. And correct me if I'm wrong, Dan, but I don't think WireGuard today is FIPS compliant, or it might not have all the FIPS capabilities, right? There might be builds that enable FIPS, but then like when I think about builds, I'm thinking about, let's say if we're talking about container images, you could probably use like a distroless or ChainGuard based image to secure that base image and then achieve your FIPS compliance or get closer to it. But that means a lot of customization on your end. Anyways, we're sidebarring off into a completely different conversation. It's just something that came up in my my thought process. All right. Enough about IPsec. Let's talk about security within Kubernetes. So we're actually going to talk about the control plane and securing it tomorrow with Mark, who is somewhere probably still watching the stream. We have a Twitter space that digs into the control plane itself and elements around securing it. Now, interestingly enough, everything within Kubernetes relies on certificates. Every control plane component is relying on a certificate in order to communicate with something else. There is trust built in there. If you did Kubernetes the hard way, you would see how that trust is built. We're not going to get into that now. Mark's like, hi. Welcome. All right. And then within Kubernetes, there's also a CR called, or a custom resource called network policies. So I touched on it earlier. It's a very basic form of being able to do firewalling within Kubernetes. You still require a CNI to achieve this, a CNI that is capable of doing this, right? Not all CNIs can do it. I'll let you all go research that. But once you have a CNI in place, you could take advantage of it. Now, there's limited functionality, which means Cilium network policy, for example, gives you extensibility and some deeper granularity in how you build out those policies. Heck, you could even create policies that protect your nodes in your environment. So we'll talk about that shortly. Authentication. Oh, no, go back. Authentication is, and we've touched on this with Mark before, around authenticating into your cluster, like actually working with your kubeconfig and working with your API server, and then also talking about authenticating to your services. And then there's access control, where we're just determining who can do what from a role sense. Like, you know, this service can maybe run a curl request against this other service, but it cannot delete, or it cannot, you know, modify resources. It can only read. And that's what we're doing with access control. And then role bindings and roles are just ways we can customize that role-based access control. All right, let's move forward, Akansha. All right. We talked about Kubernetes network policies. Do we want to talk about the limitations, Dan? Why don't you talk a little bit about that? Like, what can't we do with Kubernetes network policy? I think you call this out in the Cilium docs, if I'm not mistaken.
Yeah, I mean, it's a lot of it's kind of documented, but I mean, a lot of the Kubernetes network policies are largely built around what was kind of available in the CNIs of the day. So a lot of the network policies were largely based upon what you could kind of do with things like IP tables under the covers. With the advancements now in the way that some of the CNIs work, the fact that they can effectively understand more about who is starting the connection, can understand the sorts of data that are actually transpiring. So they have kind of layer 7 capabilities. That is the sort of stuff that wasn't available in kind of network policies out of the box when they first were kind of envisaged. It was largely point-to-point connectivity, or when I say point-to-point connectivity, it's like whatever fits within this box that you're specifying. And this box could be, let's say, a bunch of pods of this particular label are allowed to talk to the service and things like that. So that's kind of the original design for network policies. And that was kind of good for a lot of the original use cases. We effectively would put these policies in place and effectively just say that, you know, this selection of pods can only be accessible from these endpoints, or this service should only ever be accessed by these pods that are part of this particular label. Because out of the box with no network policies enabled, it's basically a free-for-all inside your cluster.
Exactly, right. And let me just kind of layer in some additional details around my time in NSX. Remember NSX from VMware? Or even
Haven't
Nicira, I
forgotten.
should really say. So at the time I was working at VMware, they came up with this concept called distributed firewalling, where every VM would have a firewall on it, right? And you wouldn't like go directly to the VM and configure the firewall itself because you're not doing it in the host operating system. You're doing it at the wrapper level, but you would do it in a central management plane, NSX manager or something like that. I can't remember. It's been years. Now, what's interesting is that idea of policing traffic right at the VNIC level is very much the same as policing traffic at the pod level, right? We're applying a policy, and either on the ingress or the egress of that pod is where that policy would get applied and get enforced. Now, there's something interesting about this too. When you think about like network optimization for a second, policy is not just a security thing. It's also a network optimization enhancement where you're now like saving bandwidth as well, because you're just disallowing unnecessary traffic from floating on the wire, which chews up unnecessary bandwidth, which actually alleviates a lot of congestion and latency and whatnot. So policy is a good thing, right? You want to have that in place when you're deploying various things in your network, whether it's in Kubernetes or outside of it. Let's move on to the next slide, Akansha. All right. So Cilium network policy. Dan, I think you're the expert. You are the expert. I'll let you take this away. Why don't you share a little bit about what this is and why we are here?
Yeah, I think actually before we kind of delve into it a little bit, I think one of the amazing resources that we've kind of put together around this is basically networkpolicy.io. I can't put it in the chat because I'm not signed in on this laptop. But if you go to networkpolicy.io, it's basically a tool for building your network policies. It makes it much simpler for you to kind of join all the dots together and do things that, kind of make it a lot easier for you to kind of build your network policies and things like that. So yeah, this is, it's a full policy editor. So you can basically, import and export your policies. You can see what they actually look like. Yeah, it does a bunch of different things. You can see there it scores the policies and stuff like that. Yeah, so this makes life a lot easier for people who want to do network policies. But yeah, back to Cilium network policy. So, from the outset, it could seem a bit like, why do we need more network policies? What's wrong with network policies out of the box? As I mentioned, kind of network policies were largely built around originally. So network policies out of the box. A lot of people use kind of CNIs like Flannel. That didn't support network policies, so you'd use an amalgamation of Calico and Flannel, which was called Canal, and that would effectively allow you the capability of A, doing the communication, and then B, being able to enforce stuff on top using Calico, which effectively did IP tables manipulation under the covers to actually enforce the rules that you were saying as part of your network policies. And that's basically as far as network policies got. They were tied to the technologies of the original implementations. And there hasn't really been much change in network policies, the original network policies that are part of the Kubernetes API spec. So in the Cilium project, it was decided that we would create our own policies that effectively sit next to the network policies, which are called Cilium network policies, which are specific to the Cilium CNI. And the power that these additional policies have are all reflected on the fact that we are completely in charge of the packets that are flowing through pod to pod, service to pod, outbound, and things like that. So with eBPF being able to have that deep knowledge of where a packet's actually going, where it's come from, what it may contain, we also have the capability of being able to understand kind of the source of truth for all of those things with the identities that we apply to your kind of the sources of traffic and things like that. We basically became obvious that we could have an extended network policy that would offer a lot more functionality. So, layer 3, layer 4, layer 7 network policy. So layer 3, a lot of it we can effectively say what traffic is allowed to leave a Kubernetes cluster. Network policies don't really tend to care about that. They tend to care about more about inter-cluster communication and things like that. We can lock things down to where traffic is actually coming from, what the source of it actually is, where it's actually going. Layer 7 is arguably the most important one that people like to talk about a lot more, and that is effectively being able to understand the source, the destination, the application type to a certain degree, which is based upon the ports, but then look inside the application. So if it's web traffic, we're able to understand that it is HTTP traffic. We can look at who is trying to access this HTTP endpoint, and we can have rules that effectively say that, you know, pods that are part of finance, the finance pod group or whatever, should not be accessing the /admin endpoint and things like that. So we have incredibly fine-grained control because we understand not only the sources and the destinations, we're understanding the actions that are actually occurring within there. We're understanding what the applications are doing and things like that as well. So it's much more fine-grained. It's there to do things that network policies originally never really envisaged to do. It would be nice for the original network policy to have all of this, but that would require, you know, kind of upstream accepting all of this, and Cilium would have to, because it's all dependent on eBPF having to be the de facto everywhere for it to be upstream like that. So yeah.
So let me ask you something, right? And this is just a thought of mine. So if I took Cilium and then deployed it directly on bare metal, and then maybe tricked it into thinking that it did have access to an API server or a Kube API server, could I technically turn Cilium into an appliance that effectively does firewalling for me at both the edge level, or sorry, at the perimeter level, as well as for my Kubernetes environment?
Yes. So one of the things that we've introduced recently is kind of external workloads, and that effectively would allow you to deploy Cilium on somewhere outside of a Kubernetes cluster and have it effectively kind of enable your pod traffic to bounce over this link to an external source. So you have a big database that you don't want to touch. It's never going to be containerized or whatever. It's an external workload that you need to access. Cilium endpoint inside your Kubernetes cluster, Cilium endpoint outside your Kubernetes cluster, link over the top that's encrypted. Network policies would apply either side as well. So we can effectively have Cilium network policies applied, which will effectively say only pods that, yeah, and this will then be reflected to the data plane inside of Kubernetes as well, which is allowing traffic to enter that external workload link and stuff like that. But yes, it is also capable to run Cilium as its own agent to a certain degree. This is something that my colleague Jeff Spalater has been doing a lot of research in terms of just having, yeah, Cilium sit there and have like acting like a host-based firewall, basically.
I love that. That's so cool. I mean, that's something that I want to, mess around with. The Michael Cade and Kat Morgan and I and a few others, I think even Leon, we're doing some stuff on the bare metal side to just bootstrap a Talos-based Kubernetes environment that's running Cilium, but could also pair up with, upstream devices, host our maybe KubeVirt environment and stuff. And I'll be honest, like I'm probably the one that's like so behind in this project because Kat's so far ahead, she's put it together. But it's a cool initiative because revisiting the data center in a different lens with some of the advancements that we've seen both on the Cilium front and even Kubernetes really enables us to like rethink how we rebuild the data center. So, all right. Let's move on to I think that's it, right? Okay, now let's take a look and see what a network policy looks like. Akansha, do you want to pull up your environment? Is Cilium installed?
It's showing me some errors like crash.
Yeah,
crash
I don't know, Dan. Maybe you can help us with that because I was trying to install Cilium today, and I just literally all the basics, like did kind with the no CNI.
Yeah, so my 4 daemon sets on like unavailable, and I don't know why it's not being up. I can like share my screen. I can show.
Dan's muted.
Oh, Dan, you're muted.
Awkward. Is Cilium is Cilium status saying anything? Is it giving any clues as to why the pods aren't coming up?
I've tried like everything. I can share my screen. Mm. Okay. Oh, like my terminal is in the main screen. I'm not able to see that option in the share screen. Oh.
So Kareem has a question. Is there any TLS proxy, or are we doing layer 7 just leveraging SNI header? How does Cilium handle performance looking at the fact that we are running on Envoy process within the Cilium agent on the node? Dan, what do you think?
It's a good question. Yeah, so I mean, Envoy is effectively doing, to a certain degree, the SSL termination that we kind of talked about earlier in some circumstances. So the Envoy process is basically taking the SSL traffic, decrypting it. We can then look at that traffic. If it is just unencrypted HTTP traffic, then we can effectively read all of that in eBPF directly anyway. So, and kind of as mentioned, these days with most of the modern CPUs and things like that, the CPU overhead for encryption and decryption is kind of negligible. Gone are the days of having kind of accelerator cards and things like that that would kind of handle like kind of all of that deep encryption and stuff like that. It's not really an issue that people really need to think that much about.
Nice. All right. Still having issues there, Akansha?
I think I need to share entire screen or something in order. Oh.
You should.
Sure.
Yeah, there you go. Oh, you just have to minimize it. Just minimize your window. And then reshare just that screen.
Okay. Oh, it still shows me entire screen and screen 1. So then it will be on
Maybe
the main
move
screen.
it to screen 1, or move that window to screen 1 and then try to share.
I think we can like work with this. It's fine. I will figure it out.
Okay.
Yeah.
You'll have to maximize a little bit. Yeah. You'll have to like maybe increase the font size. So hold your command button and then press your plus sign.
Oh, should I do it more?
Yeah. A little bit more. We need to make it really big because there's a lot of people that are like. Okay, cool. So I will admit I have the same errors, and there was nothing different than I did for this setup. So not sure why.
1 second. Okay, so what are you running underneath? Is this Docker Desktop?
Yeah.
Yeah, so there's an open issue about doing this on Docker Desktop, the latest version apparently.
Have you tried this on Kolima by any chance?
No, I'm not able to hear you.
Is it better now?
Yes.
Have you tried this on Kolima by any chance? The Kolima thing.
No.
And I hear a lot of good things about Kolima on Mac for some reason. But
yeah, so it's ARM-based MacBooks with Kind. There's something there's an issue with Docker Desktop not supporting some kernel flag or something or other. There's an issue about it at the moment. So yeah, the problem is with Docker Desktop, unfortunately.
That's okay. I am building out a Civo Kubernetes-based cluster right now on the back end with Cilium already installed. So that's a nice option that Civo offers. You can actually just go select it, and then boom, as it's installing, Cilium will get deployed alongside it. So we can go and check that in a minute. So the one consideration is most people are familiar with probably using Docker for just building out like test environments, right? It'd be really nice for us to actually do a lesson on how to use Kolima or some of the other like Docker or container-based environments, because it's kind of hard for us to just jump into it and then start using it and like making sure that it would work. So Leon, maybe I'm going to put it on you next time for you to say, deploy like, with Kolima, an environment that we can test Cilium out, and you show us how that works. And we could do that in a future stream.
Yep, that works.
I mean, also like underpinning Docker Desktop is Linux Kit, which is the thing that powers all of this. So if people want to learn about building Linux instances, feel free to go and find out what's missing from their kernel and get it fixed for everybody.
That is a very good point. My cluster has 78 seconds to go before it builds. While we're on the subject of network security and whatnot, why don't you tell us a little bit about some of the potential network security things we could see in Cilium in the future? Or maybe
I
we
think
can dig into some of the eBPF stuff as well.
That's where I was going to go.
Okay,
Largely because it's what I've been playing with in my spare time. But yeah, I think for me the biggest thing that, and we're starting to see this already. I mean, Tetragon does quite a lot of this already, is protocol support. So by default, when a packet arrives and eBPF sees that packet, it's very simple and easy for it to understand the layer 2 frame, the layer 3 IP header, the layer 4 TCP or UDP config and stuff like that. The rest of it is basically just nonsense. It's bytes. It's this, that, and the other. And being able to, so we've already mentioned network policies can do things like HTTP parsing to determine what's allowed. We also do Kafka, but it's a case of kind of adding more logic into your eBPF program so that we could understand things like DNS, which I did an example of last week, or BGP. So being able to say what routes are allowed or what routes aren't allowed and things like that, all the way to MariaDB or MySQL. Like for instance, you have a policy now in your kernel that if ever we see a drop tables all or whatever, like that just never is allowed. And we can effectively say our kernel is now programmed to basically never let this sort of thing ever happen. If it ever sees it, and we can understand that it's like the MySQL protocol, then we simply just won't allow that sort of behavior. So I think, and it's kind of funny, I really like it because people said this wasn't possible. It's the sort of thing that eBPF, you can never really do with eBPF, and like that's just not the case at all. So yeah, for me, I'm like super jazzed about this whole thing at the moment. Sticking more logic into eBPF is my thing for the future. But it's everybody's thing, but I'm just super happy about it.
Love it. Okay. All right. So I got a Civo Kubernetes cluster up and running, and if I do a kubectl get nodes, you can see that I've got my cluster up and online, and we can even verify that Cilium is installed by running a Cilium status against it. And oops, if you see here, my Cilium is okay, my operator is okay. Cluster Mesh, Hubble, and Envoy are disabled. So Envoy, we use it in Cilium for its service mesh functionality, and I think Gateway API too, right? Right, Dan? Yes. Okay. And we'll revisit that later on. We don't need to talk about that today. Hubble is another cool tool for observability. We'll come back and revisit that maybe next week or the week after. And Cluster Mesh, I love Cluster Mesh because it's a technology that is very similar to how we used to build remote networks and connect them together with IPsec. But Cluster Mesh is mainly used for allowing us to combine multiple Kubernetes clusters and treat them as if they're on the same fabric, so that pods across these clusters can find each other and communicate, right? It's really cool. So we've got Cilium installed, except look how old I think this version is. I think it's 1.1, 1.11.
I was just thinking that. It's like 1.15 was announced last week.
Yeah.
Yeah.
So if I do a Cilium version right now, because I've got the Cilium CLI, it tells me that the Cilium image running is 1.1, 1.6, and I've got updated versions, but I don't have 1.15. It didn't let me pull it down. So that's okay. We could even come back and update that, but I want to upgrade this. So if I do a Cilium upgrade, technically it should just work. Do I need any other additional flags?
I don't tend to use the Cilium tool all that much, so
Okay, well, let's see what happens.
I mean, effectively, it's Helm under the covers anyway, so it's
Yeah. All right, let's do a Cilium status and see if it's working.
it's restarting at the moment.
Okay, and then do another Cilium status in a couple of seconds.
Oh, they're coming up now. We've got some ready.
Looking good, looking good. We're getting there. And then I should be able to pull a quick network policy example for us, because I had it somewhere here and now I don't know what I did with the window that I was looking at. Dang it. See, this is one of my challenges when I have 500 different windows open at the same time. Quick installation. All right. Let me check Cilium status again.
There we
Love
go.
that. Nice. It's looking healthy. Okay. So what we're going to do is we're going to deploy an app called the Star Wars app. For those that are curious where I got this from, I'm actually going to paste this into the chat so y'all can find it. It is at docs.cilium.io, and it's the Star Wars demo. And if I do a kubectl get pods-a, we see that it's creating, right? Gets pods-show labels. Show labels. Because one thing I want to point out is the way we issue in process policy is heavily based off of labels. And so if you notice here, the TIE Fighter, right? The TIE Fighter pod that's running now has two labels. One is called class TIE Fighter, and the other one is called org Empire. But if you notice the X-Wing here, it's got a name of X-Wing, it's got a class of X-Wing, and its org is Alliance. The only other two pods that have the org equals Empire are the Death Star. So that should be indicative of something that we're going to do with our network policy. So one of the things we want to do with our network policy is effectively just prevent the X-Wing from communicating with the Death Star. So I will run a curl command just to verify that we can do that. So we'll exec into the X-Wing pod, and then we'll run a curl against the Death Star. And this should work because I have no policy, right? I have no policy in place. And if I do the same thing with the TIE Fighter, by the way, for those that are familiar with Star Wars, you would know that the TIE Fighter and the Death Star are part of the Empire. And then the X-Wing is like part of the Rebels and whatnot. So anyways, a little Star Wars trivia for y'all. Okay, so we know that it's working. So technically we want to prevent the TIE Fighter from talking to the, sorry, not the TIE Fighter, the X-Wing from talking to the Death Star. So we're going to apply a network policy, and there is a network policy we can look at. So let's do a vi sw at netpol.yaml. And I'm going to paste this in. And if we look at this Cilium network policy, it's not a Kubernetes network policy, right? L3, L4 policy to restrict Death Star access to Empire ships only, meaning if I am coming in to the Death Star Death Star itself, the pod, right? I have to have a label that matches org equals empire. And I'm communicating on port 80 for the TCP protocol. Now, if I don't have this label, what do you think happens? There's actually an implicit default deny all that's hidden here that says if you don't have this, it's implicitly stated there. We don't have to state it here, but because we have this policy in place, right? Once I apply it, technically speaking, I should not be able to. So hold on, we're going to do this with the TIE Fighter. Will this work? Yes. Now, will the X-Wing work? What do y'all think? What do y'all think? Yes? No? Maybe? All right, it didn't work. So we could even see, we could even do a curl-v if we want to see the output that it's trying to connect, but it won't make it. And that's because the Cilium network policy, see, we're trying that pod IP, just won't work. Or the service IP should really say. It won't work because the policy is taking effect. And if we do a kubectl get Cilium network policy, we see it right there. So it's there, it's taking effect, it's preventing the X-Wing from communicating with the Death Star. Dan, I feel like you have something you want to add to this.
No, that's it. I always find it interesting. There is reasons why we don't basically just send a TCP reset. So effectively the connection kind of is left kind of hanging. We don't need immediately send back, like this is just not going to happen. So I suppose that can be a bit confusing when you're showing it as a demo, because like it looks like it might work, but it never will actually connect. Like the TCP connection will just time out eventually. Or the TCP will never establish, basically.
Oh, Marino, you're muted.
Yeah, so the key idea here is that we want to make sure that the labels here that we're seeing that's the key here. We're using labels. And why this becomes important is even if our pod IPs change, right, we shouldn't care. The pod themselves change, we shouldn't care. If we decide we want to deploy a new container image, that shouldn't matter either, because the deployment artifact that we have will have a label that gets injected every time this new pod gets created. But that is network policy in a nutshell. We have so much more to explore, but we are out of time. So
I would like to, there's the point at the bottom though. Somebody's asking if we can use Hubble to visualize the drop traffic. And like, yeah, I think we really don't talk about Hubble anywhere near as much as we should do. Like, just if you have a service and like, you want to do a kubectl expose, this, that, and the other, and you get the label wrong, like you'll be sat there like hitting that load balancer IP, like why doesn't it work? You'll have to then kind of look at the labels of the pods you're trying to access and the labels specified in your service and stuff like that. If you basically just open stuff up in Hubble, you will see the broken connection. Everything that we've just talked about here, like why can't the X-Wing land on the Death Star? We will see policy denied. Like all of this stuff that people have had to like hand unpick to work out why their stuff wasn't working just is visually there in Hubble. And it's like it makes life so much easier. You can see it like from a UI perspective, or you can basically just have it dump everything out from a CLI perspective as well. And for all of this sort of stuff, it makes your life so much easier.
I love it. All right. Well, I just want to say thank you all for coming by today. We will continue the streaming next week. We'll maybe go into part 2 of network security and explore some more network policy. Maybe kick up Hubble and see how all of this plays out. Maybe use some of the network policy editor that we took a look at just not too long ago. But again, just want to thank you all for joining again. Thank you, Dan, for the expertise as always. Thank you, Leon. Thank you, Akansha, for joining and hosting as well. We will see you all next week. Take care, everyone. Have a great week. Have a great day, great afternoon, great evening, wherever you are. Take care. See ya.
Catch you later. Thanks.